Hey guys, today we are looking at normal distribution. A normal distribution is another type of probability distribution modeled by a bell-shaped curve called a normal curve that's symmetric about the mean. So that means the mean falls right in the middle, and you can see that in this first normal distribution curve. So a normal distribution with a mean of x bar and a standard deviation sigma has the following property. The total area under that curve is 1. So if you add up all of those percentages, it will get you to 100% or 1. 68% lies within 1 standard deviation of the mean. So that means we add 1 standard deviation and we subtract 1 standard deviation. You can see that 68% lies in there. So 1 standard deviation above, 1 standard deviation below. 95% lies within 2 standard deviations of the mean, and 99.7% lies within 3 standard deviations of the mean. So then you can see specifically the breakdown here that if 1 standard deviation on both sides is 68%, then each of these are 34%. And then this is 13.5, 2.35, and then 0.15 as you get further out. So what you're going to see are problems like this. A normal distribution has a mean of x bar and a standard deviation of sigma. For a randomly selected x value from the distribution, find the probability of the mean minus 1 standard deviation up to the mean plus 3 standard deviations. So I'm going to draw this in that right here in the middle is our mean. And then I need to go 1 standard deviation less. And then I need to go 3 standard deviations more. So it's all of this area, and I need to know what is covered in that area. So remember that this is 0.34. This is 0.34 because that whole thing was 68%. Then this is 0.135, and this is 0.0235. So if we need those pieces, then we have 0.34 plus 0.34 plus 0.135 plus 0.0235. If we add all of those up, then the probability would be 0.8385 or about 83.85%. So you do need to know the breakdown of the standard deviations. The nice thing is it's symmetric on both sides, so that should help you out. All right, another type of problem that you will see is something like this. The price of sandals is normally distributed with a mean of 36 and a standard deviation of 9. What percent were priced between $18 and $72? So what I want to look at is I'm just going to draw in a curve here. So my mean is 36. And then every standard deviation is 9 away. So I'm going to draw until I get to those values that I need. So 36 minus 9 is 27. That's 1 standard deviation away. And then 18 is 2 standard deviations away. I'm going to go ahead and go down to 9, 3 standard deviations away. And then on the other side, if I add 9, so 1 standard deviation is 45. And the next standard deviation is 54, and then we're up to 63, and then 72. So I want to know what percent is priced between 18 and 72. So for this one, I need 18 to 72. So you can fill in those pieces individually, or you could look at knowing, in that first one it told us that 2 standard deviations, so from 18 over to 54 was 95%. And then we also want to know all the way up to 72, so then that was 0.0235 or 2.35%, and then 0.15%. So I would do 95 plus 2.35 plus 0.15, and I would get 97.5%. And then for B, it says, what is the probability that a randomly chosen pair is priced between $9 and $18? So 9 and 18 is this little piece right here that we're 1 standard deviation, 2 standard deviation, 3 standard deviations away. And so that is 2.35%. So that's just being able to read your table and know what to put down there. Okay, the weight of strawberries packed in a medium-sized container is normally distributed with a mean of 16.18 ounces and a standard deviation of 0.34 ounces. If you randomly choose 2 medium-sized containers of strawberries, what is the probability that both of them weigh less than 15.5 ounces? Okay, so there's a few things here to note. First off, let's draw our normal distribution. So 16.18 is my mean. And I want them to be less than 15.5, so I need to go this way because I need the numbers to get smaller. So 16.18 minus 0.34, I get 15.84, and then minus 0.34 again, I am at 15.5. So I want everything over here. So I know that that is 2 standard deviations away, and then the rest. So we have 2.35% plus 0.15% if I'm looking at my table. So that's 2.5% or 0.025. So if I want both of them to weigh less than 15.5 ounces, the probability of that, the probability of one of them is 0.25. So I want the first one to weigh that, and I'm going to put it times since I'm saying and, the second one to weigh that. So then I get 0.000625, or about 0.0625%. So there's a very small chance that that will happen. All right, normal approximation of binomial distribution. So this is saying that when n is large, it can be tedious to compute binomial probabilities using the formula that we just looked at in our last set of notes, the binomial distribution formula. So if both n times p is greater than or equal to 5, and n times 1 minus p is greater than or equal to 5, then the binomial distribution can be approximated by a normal distribution with a mean of n times p and a standard deviation, sigma equals n times p times 1 minus p and the square root of all of that. So basically what this is saying is when you have a large enough number that when you take the number of opportunities times the probability of it happening, and it's greater than 5, you can use these two formulas to approximate, because not all of your data is going to come out nice with nice standard deviations like the past two examples we've done. So suppose that in a nationwide poll, 72% of households owned at least one car. You conduct a random survey of 129 households. What is the probability that at least 98 of them own at least one car? So the number of households is 129 times the probability, so 0.72. 129 times 0.72 is 92.88, so we're above 5. So far, so good. Then we need to also do 129 times 1 minus 0.72. And so that would be 36.12. So again, we're good. So then our mean is just n times p, which we already did. So that's 92.88. And then our standard deviation is the square root of n times p times 1 minus p. And so you can write 1 minus 0.72, but we know that that's 0.28. So then I get the square root of 26.0064, which is about 5.1. Okay, so we want to know the probability that at least 98 of them own at least one car. So 92.88 is our mean. If I add 5.1 to that, I get about 98. So 92.9 plus 5.1 gives you about 98. So we want to know the probability of all of this that at least 98. So 98 or more people. So you could add all of those pieces together, or another way you can look at that is knowing that over here, this is 1/2, because your mean splits it directly in half on a normal distribution, and then one standard deviation is 34%. So you could do 1 minus that 0.5 plus 0.34, or 1 minus 0.84, and get 0.16, or approximately 16%. Well, we are going to skip over this. So standard normal distribution. A standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So this is another way to deal with when your numbers aren't coming out nicely. This is how you can deal with things. So it's used to change x values to z values, and we have a z value chart to help us with this. So a z-score is what the z value for a particular x value is called. It's the number of standard deviations the x value lies above or below the mean. So this just takes your mean and turns it into a z-score of 0. So then 1 standard deviation away is a z-score of exactly 1, and so on. So if you look here, we have a z-score chart. And so when you are reading this chart, what it means is that it's always the probability that it is less than the number, or less than or equal to the number. So the highlighted piece here that you see says if z is randomly selected value from a standard normal distribution, you can use the table below to find the probability that z is less than or equal to some given value. For example, the table shows where z is less than or equal to negative 0.4. So if you want to know where z is less than or equal to negative 0.4, we need to go to negative 0, which seems a little counterintuitive, but negative 0, and then go along the columns until you get to 0.4. And so you can see where it matches up at 0.3446. If you want to know where it's greater than negative 0.4, then you would just do 1 minus that value because it would give you everything else. Okay, so 2 practice problems there for you. Pause the video, try it, and then we can go over it together. So we want to know where p is less than or equal to 1.8. So I'm going to go in the z column and find the 1, and then I'm going to go over to 0.8, and I get 0.9641. Now, I want to know where p is, or where z is greater than negative 2.7. So that's the opposite of what I find in the table. That's 1 minus what I find in the table. So I'm going to find negative 2.7. So I'm going to go to negative 2 and go over to 0.7. I get 0.0035. But I need to do 1 minus 0.0035, and I get 0.9965. All right, let's practice switching an x value over to a z-score. So scientists studied groups of teenagers at a mall and recorded the number x of teenagers they observed each survey. The number of teenagers observed were normally distributed with a mean of 52 teenagers and a standard deviation of 15.4 teenagers. Find the probability that at most 25 teens were observed during a survey. Okay, so the numbers that we have here are the 25, the 15.4, and the 52. So we want to know the probability that at most, so less than or equal to 25, were observed. And so we want to know what that is in a z-score so we can look it up on our chart. So our z-score is our x value minus our mean over our standard deviation. So our x value here is 25. Subtract off the mean of 52 and divide by the standard deviation of 15.4. So we get negative 27 over 15.4. which is about negative 1.75. So our table that we have to look at only goes to tenths. So I'm going to go ahead and round that to negative 1.8 just to look up in the table. So now, instead of x is less than or equal to 25, I want to know the probability that z is less than or equal to negative 1.8. So go back to that table. I'm going to flip back here and find negative 1.8, and I get 0.0359. So 0.0359 or 3.59%. All right, guys, that's all I have for you today. If you have questions, come in and see me. Otherwise, I will see you in class.